We're booking right along. We're on lesson 20, talking all about triangles today. You got two objectives there. Let's go ahead and get started. This is one of my favorite fun facts of the day that we've had. It is estimated that millions of trees in the world are accidentally planted by squirrels who bury nuts and then forget where they hid them. So a squirrel buries a nut in the ground, intending to come back and eat it later, forgets about it, and then nobody knows that it's there, so it ends up being a tree after, of course, some rain and some fertilization, all that kind of stuff, which is pretty awesome. Alright, we have to be able to classify a triangle by sides. We have three different types: scalene, isosceles, and equilateral. Make sure you spell this word right, please, on your notes. Okay, I'm not saying you're going to spell it right all the time on your assignment, but please make sure you get it right in your notes, because that's a tough word to spell. Alright, a scalene triangle means that that's a triangle that has no sides or angles that are equal. No sides or angles that are equal. And the way we show this in geometry, you'll see this a lot in geometry, by the way. So if I mark the length of the side, or if I want to tell if sides are equal or not, a lot of times I'll do this. One mark on a side means that it's a certain length. And then if a different side has two marks on it, that means that it is different than this one. Okay? This one's got one mark, this one's got two marks. So then to show all three are different, we've got to make three marks on this one. So that means that all three sides are different. Okay? An isosceles triangle has at least two sides and angles that are congruent. Okay? That are congruent. Why did I put the word congruent? Because I want to make sure you understand that means the same thing as equal. Okay, it's a good geometry word though. At least two sides and angles that are congruent. Okay, so again, in an isosceles triangle, maybe if I say this side is a certain length, this side also has to be the same length. Okay, because isosceles, these two sides are the same. So they get the same number of these marks. This one is different, so it gets a different number of marks. Alright? So that's how we show that that's an isosceles triangle, that these two sides are the same and this one's different. Okay? Now, it says at least two sides and angles. So something that has three sides, a triangle that has three sides and angles where everything is congruent, is isosceles, but we have a different name for it too, and that's called equilateral. Okay? So all sides and angles, okay, that's important, all sides and angles are congruent in an equilateral triangle. So that would mean that this side is equal to that side, which is equal to that side. Okay, we can show that with angles too. This angle is equal to this angle, which is equal to that angle. I'm going to go back and show that in these other shapes. Well, this angle and this angle are the same, but this angle is different. Okay, in an isosceles triangle, the angle that's across from the sides, okay, are the equal ones. And in a scalene, we'd have that one, and then this one would have to have three. Okay, because they're all different. Alright, so equilateral, another name that you want to know for that is equal angular. Okay, so it's equal angular, and I would put another parenthesis over here, but I kind of got off track there. Maybe we can scooch this over a little. There. So equal angular is another name for equilateral. Okay, let me erase that and write that a little better. Oh, nope, it's not going to let me erase it. Okay, well, that's a good try. But equal angular, that's EQUILANGULAR, is another name for equilateral. Because lateral talks about sides. All sides are the same. So this literally means equal sides, and this means equal angles. Alright, so let's go ahead and move on. This says classify triangle ABC by angles and sides. So triangle ABC here by angles and sides. Well, if I look here, okay, this angle right here tells me it's a right angle. And this mark tells me that these two are different. This is not a right angle. And since this one doesn't have a mark like the other one, that means it's different. So this one has all three angles that are different, which means all three sides have to be different. So this is a scalene because all the sides are different. Okay? And then we already learned some names for triangles. If we classify it by angles, okay, then we just look for the biggest angle. Well, the biggest angle is a right angle here. So this is a scalene right triangle. Okay, and this is important to make sure you got it classified by both sides and angles. Scalene right triangle. Alright, let's go ahead and move on. Roof of the building in the drawing slopes 35 degrees. What is the measure of the angle at the peak of the roof? Okay, so they're asking for the measure of this angle at the peak of the roof right here. Well, we know, you should know coming into this class, that all triangles have 180 degrees in them. Okay, so if I know this one's 35 and this one's 35, I know I've used up 70 degrees so far. And I want to know how many more degrees I can add before I get to 180. Okay, there's a nice equation for that. The amount of the angles I already have, 35 and 35, plus my missing angle have to equal 180. So I would solve this by subtracting 70 from each side, and I would get 110 degrees is the measure of the angle at the peak of the roof. You have to excuse me for my sloppy writing, because my stylus is about to break actually, which bums me out, but I'm going to try to do the best with it I can for the rest of this video. Okay, so again, all I did here is I added up the two sides I knew already, and then I ended up subtracting them from 180 degrees, but this is an equation to kind of prove why that method works. Alright, so we also have to talk about area of a triangle. How do we find the area of a triangle? Well, first thing I drew here is a rectangle, okay? We know the area of a rectangle. Area of a rectangle is length times width. Another way to say that is base times height. Okay? We can take its base right here times its height. Okay, now height is always a straight up and down line, okay, or a line that forms a 90-degree angle with another line. Okay, so that's important here. A height, stylus, again, trying to manage, hang with me here. A height, a height is a segment that forms a 90-degree angle with another segment. That forms 90 degrees with another segment. Okay, so it's a line in the shape that forms 90 degrees with another line. That's what a height is. So that's why in this case, for this rectangle, I can say base times height, because the base and the height make a 90-degree angle. Okay? Well, think about a rectangle. I can split it into, let's say I want to split it into two triangles. I could easily split this down the middle in half into two triangles. Okay? So, the area of one of these triangles, if I want to color this in here, let's say I want to find the area of this triangle. Bear with me here because my stylus just completely broke, so we'll try to make do here. Okay, the area of a triangle is half of the rectangle, so that's a half of the base times the height. Okay, because the triangle is 1/2 of the whole rectangle. So we need to make sure that we know this formula right here. And again, we need to know that the height is always a segment that forms a 90-degree angle with another segment. So this is a height and this is a height because it forms 90 degrees with this one still. Okay, so let's go ahead and move on and apply this. Alright, so here we want to find the area of each triangle. So for letter A, letter A, again, I'm going to write down my formula. It's 1/2 times the base times the height. Some of you like using base times height divided by 2, which is the same thing. Okay, well in this case, I got to remember my base and my height have got to form a 90-degree angle. Okay, so in this case, my base and my height are right here. These are the two sides that form the 90 degrees. So I'm going to plug these in. 1/2 of the base. The base is usually the one that goes side to side. Doesn't always have to be though. But then the height is the one that makes a 90-degree angle with it, which is 6. Okay, notice we don't use 10 because there's no line. This line doesn't make a 90-degree angle with 10, and neither does this line. Okay, so I take 1/2 of 8 times 6. Well, I could take 8 times 6 and get 48, and then do half of that. That's just 24. And its area, so I label inches squared. Okay, I could have done half of 8. Half of 8 is 4, times 6 is 24. Either way. Alright, so let's do B. A little trickier when you get a shape like this. Okay, so again, my base and my height. I'm going to take 1/2 of the base times the height. Alright, the base is going to be this side right here. Now if I extended this base out, okay, I would need to draw this segment that makes a 90-degree angle with it. So my height is actually right here. Notice it's from the top of the shape straight down to the bottom. Okay, because it would form a 90-degree angle with the base if the base went over here. Okay, there's no line in this triangle that could form a 90-degree angle with this one. So this is my base and this is my height. I see the 90-degree angle formed by those. Okay, I'm not worried about this extension of the line here. I'm going to use this right here as my base. So it's 1/2 of the base, which is 6. This 6 right here, and then the height makes the 90-degree angle with if I continued that segment out. Okay, so again, I can do 6 times 6, that's 36. Half of that is 18. So it's 18 centimeters squared. I could have done half of 6 is 3, and 3 times 6 is 18. Alright, let's do the last one. Again, triangle formula, 1/2 of the base times the height. Okay, well in this case, I can see right here again, here's my 90-degree angle. So that means this segment and this segment are the ones that are the base and the height because they make the 90-degree angle together. Again, there's nothing that makes a 90-degree angle with this one. So here's my base, here's my height. I'm just going to plug them in. 1/2 of, whoops, I don't want to write the B again because I know the base. It's 8 and the height is 7. 8 times 7 is 56. Half of 56 is 28 meters squared. Alright, our whole lesson on triangles. If you have questions, please make sure you get them asked. Happy homeworking and enjoy those assignments.